start the presentation, we're going to be comparing two products. Here we have a Sniffer configured system. As you all know, looking at an Ethernet version, PA402, Sniffer running in a compact portable tube as you get it from the factory. Here we have the equivalent from Exelan packaged in same machine, compact portable 2 hardware. Exelan refers to that as their EX5500E system level product. We're now running Exelan's version 2.0 software, which is their latest and greatest software. And on the right, we have our current release software version 1.30. Now, actually, there's a little bit more to the story. The Sniffer normally only is sold as a system level product. You take it out, you turn it on, that's the screen you get. We really didn't start the LANalyzer this way. We had to start with a board, as most people do, plug it into a machine and get it working. Let me share with you a quote from PC Magazine. PC Magazine editor tried to install the Exelan kit in his 8 MHz IBM AT, the industry standard, a few months ago, before the PS2s. He discovered that this board, this time it was the Exelan 225 board, the same is exactly true for the Exelan 325 board, which is their current model, doesn't work as shipped in an 8 MHz AT, which is the only kind IBM sells these days. It works only in the old 6 MHz AT. In order to change that, it turns out you can't run it in one of the 16-bit AT slots. You've got to put it in an 8-bit slot. And to do that, you have to change a whole bunch of jumpers, and eventually it starts to work. James here, last night we were talking about some of his experiences. And in fact, going through, I guess, somewhat similar exercise in having gotten the Exelan board and spent his Christmas vacation one year trying to get it to work. And of course, eventually succeeded. Like all good things in life, it's not impossible. But is this a fair reflection of some of the agony you go through?
I would say so.
And he'll be a good reference, and I think any Exelan customer is a good reference on the difference between starting with the board level product and starting with the system level product. Having suffered through that step, we finally get to the point where we follow the instructions, we install the software, we turn on the two machines, and this is what you see. The Sniffer presents its user immediately with user-friendly menu. You can figure out what to do to run his Ethernet Sniffer. The LANalyzer, this is what you see. You follow their instructions. Now you're faced with a good old-fashioned DOS prompt, and it's wonderful for your traditional DOS hacker. It doesn't, by the way, have anything to do with whether you're looking at it on an internal screen or an external screen. We had to, again, read the secret code that if I press Control-Alt greater than, that actually displays my output on an external port on a compact. That's, again, not available in the form that we do. And I'll keep coming back to this. There's a very different philosophy in the human interface, communicating users, in trying to deal with someone who's not a techie, and so on. The way you work with LANalyzer is you now figure out that you've got to type LANZ, and it's going to go load the LANalyzer program. Let me mention, in your handouts, you have, in the packets, a couple of sheets called Know Thine Enemy. And basically what this is a checklist of features in doing any kind of product comparison. It's not a side-by-side comparison of our products versus anyone else's products. It just talks about the kinds of features that may be very important to customers. Ease of use without training. Can you just turn on the unit and start to work? Let's say one word about the display here. We spend considerable effort in making sure that the Sniffer screens were readable in an ideal fashion, whether you're looking at a color monitor, a black and white monitor, external LCD. One of the predicaments in this presentation is, there are two choices in the LANalyzer. You can tell it that you're working on a color screen or a mono screen. Neither of those looks very good on a green compact screen. We have a special mode where we take advantage of all the 8 levels of gray that a compact computer offers. They don't. But to make it a bit more frustrating in this demonstration, despite whichever mode you choose, they've shown a lot of the detail that I can see on the screen in front of me, the actual screen, does not come out in shades that this kind of LCD screen does. They're not using, even when they're in monochrome mode, they're using highlight and low light characters. In fact, if I go down here, you'll see there are other words in this column. And at the moment on the screen here, I'm seeing one of them highlighted. They are dimly shown on the glass screen in front of me. This is going to make this presentation a bit tricky, but it does, I think, give you some feeling about the lack of attention to detail. I've seen an even worse example of a LANalyzer. Someone showed me their LANalyzer running on a plasma machine, such as Toshiba, whatever it's called, laptop. And it's the same kind of problem. You plug it in, you turn it on, and guess what? You can't see things. They've used intensity levels that are just invisible on that screen, just the way you have a problem with an LCD screen. And those are the kind of problems you run into with any board-level product. You get a lot of customer questions that he puts it in his machine, says, why can't I read the screen? So we're sort of simulating a laptop here. Okay, the system came up, and right away we notice we're left in the main menu, and here the organization of this system is everything is controlled by function keys along the bottom, and you'll see in a minute how that works. One of the first differences, the keys here are very simple. You turn on, there are 2 buttons that make sense. One is help. Pretty obvious. You lost, press help, pick something, okay, find out how it works, get back. The other thing you might want to do is capture data. That seems like a reasonable thing to do when you start using this kind of product. It comes up, and you can either hit the carriage return key, or you can press F10, new capture. F10 and capture seem to be the logical things to do at this point in time. Begin data collection from the network. I can just do that. It comes up, does stuff. Anyone want to guess now? First time LANalyzer users, everyone else, hold your experienced folks out there. What do I do to start collecting data here? What is it showing me on the screen? It's all talking about setups and what packets it's going to talk about and how to configure the machine. And I challenge you to tell me how it is I start looking at what's going on in this network. F7, he says? Wrong. 10. There's no help either. Let me tell you the answer. You know, the answer is bring your LANalyzer manual. I mean, that is, you know, I think we have a wonderful manual. It's award-winning. Everyone thinks it's great. It's a good reference material. It's far better than the quality of documentation they have. The sad thing is the documentation writers, no one ever uses it. They turn on the damn thing, push a couple of buttons, and they're offline. You don't go anywhere without your LANalyzer manual. You stick with it. 7, he says. Well, let's play 20 questions. Okay, you tell me what to do, and we'll push the keys. Okay. Well, I don't think that was it. Now what do we do? Back. 10 is back. 9 is more. Watch those keys. 10 is back. Okay. 3, he says. Mode. That's an interesting one. Mode. Go to the capture mode. That's great. Mode. Filter information may be lost in mode change. Proceed, yes or no? No. No. Just like that. Go for it. Well, maybe that was it. I mean, maybe it's under mode. Command. Command. Okay. Command. There we go. Okay. Now what?
Run.
Run. Run what? This is, I better set something up. Maybe I should trace packets. Oh, I want statistics about the network, right? So I should press the statistics button. That's not what stats. Trace sounds more logical. Bill was right. Run is the code word for collecting data. Okay, it's running. Tell me, that's a good question. Why is it not?
90% utilization for
Okay,
broadcast.
good. Okay, so man said the network is 90% busy, I guess, right? And we say the network is 100 frames per second busy. Let me change that. I'll press. Notice this keeps me up here. Pause. Close my capture options. Now let's change this to network utilization. Okay. And go back. Linear. Oh, great idea. How busy is the network?
12%.
Yeah, 12%. How busy is this network? Right. What it's telling you is this really important thing. Okay? It's telling you that of all the packets it's looking at, 100% of them happen to be collected in this channel, filter. And of those, only 90% are this. But how busy is the network? I mean, why is this so important? It's not necessarily the most useful piece of information. This again, for someone who is looking at a very specific problem, there are ways you can use this information, but it's not necessarily the right answer. By the way, have we lost any packets here? Or which machine is keeping up with the network? We'll talk about that.
What was your question again?
Tell me which network, which of these two, how much of the data are we collecting or losing or whatever is going on. Here we show the 100% buffer utilized, right? Which means, in fact, we've filled up the amount of buffer in that machine. And at this point, the data is in wraparound mode. That's the way we have it. And in fact, there's lots of stuff going on, but we're losing it. Let me clear the screen. The moment traffic is being generated, normal kind of Ethernet traffic on that machine over there. Could you hold it down for 1 second? Okay. Stop. Traffic is coming in. Notice we see the buffer counting up. It's showing us, how much of it's in use. Eventually, 100%, and then if we don't tell it to stop, we'll lose data. Okay. What's the equivalent over here? The equivalent over here is actually this thing called packets not saved. Okay? Packets not saved means ones that it hasn't saved in its memory or disk. Okay? So what it's telling you is sort of how far over the hill it's been. If I stop this and restart it, okay, there's again a somewhat different point of view. It's not telling us how full it is. It'll just tell us the minute it starts losing stuff. When it starts losing them, suddenly this will start counting. Okay? And again, it'll be in a mode where, it loses the older stuff, exactly the same. Okay? So here, we don't know how soon we're about to run out of memory, so how busy is the network? We never didn't quite see that, and what stations are talking to what. Again, this project is trying to give us some information right away, like this bar chart. We just saw burst of broadcasts happen on the network. How do we get that kind of information here?
Stop. Take a look at some of the other view.
Okay. Stop. Okay. This global statistics here is showing us how busy the network is. Okay. In the last. Pressing start doesn't want to start. More. Global. Okay. The network's running. These counters are going up here, and what we see here is how busy the network is. Okay. And let me show you the same thing over here. I'll go to my menus. Turn on Skyway. Basically, this system is set up to show you 1, 2, 3, 4, 5 history points. 5 seconds, 5 minutes, 5 hours. That's what you see. Here, what we're seeing is 80, get the exact number. Time points, whether those are seconds, which is right now, these are topical. Okay, and when we scroll off the screen, as we saw yesterday, we can go backwards and see what happened. Well, we happen to be looking at two phenomena here, both the amount of traffic as well as the number of stations that are utilizing the network. In this case, what it's presenting is 5 points as to utilization, and then it's showing us averages for the last 1 second, 5 seconds, 10 seconds, and 20 seconds. That's potentially interesting. Over here, can't see it too well, but this actually says 0, 64, 128. 60% of the packets are between 64 and 128 bytes. And then so many are between 128, 256, and so on. And that's the level of global information. And here we can go back and get a picture from across the room about what's happening, scroll back, see what time of day it happened, and so on. A very intuitive sort of way. There's a lot more training just to figure out what all this information is. My own view is that not all of this is that relevant. It's presenting a wealth of information, such as this packet size distribution. All right, let's see who is using the network. Again, we'll just go back to our runtime display, and we can go, let's say, into pair counts. And now we're going to see, in this case, we don't have names in it, so we can see, suddenly these two stations start talking to each other. Okay, so that little burst of activity. A couple of stations of broadcast routing. Okay. Start to see the conversation. You can see pairs of conversations. Here's a big burst of traffic between these two, and I can go in now and assign their names. How do we do that with the LANalyzer? At this point, you really do need to get out your manual. And now, I go to Setup, and I search around on here, and I have to turn that option on. By the way, how did I turn that option on? Shift plus. That's right. How did I remember? Notice the Sniffer menus. Give me an example. Here we say things like, should you do this? Press space to select this option. Other kinds of supportive things to let people know what's going on. Okay? How do you do that? Here, actually, it's right there in front of you. Why you all didn't see it is a mystery to me. Here it says you press the plus or minus key. In case you forgot what key is active, it's right up here in front of you. You didn't know that. You knew that all along. Okay, so that's their online prompting to find out what you do. And in fact, you press the plus or minus key. That's it. Yeah. Okay, so we're turning on station monitors. Great. Now we want to see something like that. So I go back and I collect data and run. And now I can press this button, I think 6, station. Notice here what we're seeing is the source and destination. Okay, 2 stations have been on the network, and it's showing us that he sent 1 kilobyte. Changes the frames. Okay. just saw a whole bunch of stations talking to each other, who is transmitting to who. We get some idea of the source and destination. What's happening here is rather different. It's just giving us a list of the addresses on the network. Okay? It's showing what they are, and it's telling you that this station sent 32 frames and received 32 frames and transmitted, but no idea of who's talking to who. So it doesn't have any kind of connectivity or matrix or whatever, which typically you do get with the sniffer. These two stations just had a lot of activity together. You'd have no way of finding it out here, literally. It does have one advantage. You actually can scroll off the screen here, and it will keep up to a large number of stations. Unfortunately, in this mode, the sniffer will keep up with thousands of packets per second. And in fact, all the screen changes were made, and all the changes, the sniffer still keeps up with thousands of frames per second. This unit here is seriously losing data, and these counts, and we'll publish the exact numbers, are incorrect. It is not able to keep up and keep these counters correct in real time when it's in this mode. So just because you have this information, it may look very impressive to know that there was, there were no packets from this station. Unfortunately, that's not a valid conclusion. It can handle only something in the order of 1,000 packets per second and not miscount, misrepresent what's going on. Whereas the sniffer can do this in this mode at close to 5,000 packets per second. This is a dangerous mode. This is probably the mode that lots of people like to, would like to use the station monitor in. Part of the predicament is it's trying to keep track of things like the average packet size and the average receive size and the average transmit size. All that takes valuable horsepower away from what we have here side by side, two identically powered engines. We're sitting with two basic compact 2 8 megahertz 286s. And if you don't pay a lot of attention to the detail of programming, and if you do lots of other calculations, you run a serious risk of basically lowering the rate at which you can take data. Okay? This is probably one of the main distinctions among the products. We try and do things very efficiently and keep performance very high. Here they have some very interesting statistics that are being kept, but there's a severe penalty for those. Give me another example. Everyone knows that this machine can capture data to disk. The sniffer cannot capture data to disk. Why don't we capture to disk? How do we do that? I don't know. Okay, well, somewhere back in our friendly setup file, there's a place where you can set up the name of a trace file, and I believe if you simply put in a name there, then statistics will go there. Okay. At this point, let's see, Gary, how would you like to generate some traffic over there?
The keyboard got ripped out of my hand.
Okay, well, whoever has the keyboard.
Oh boy, I know.
Okay.
I know how to do this one.
Okay, let's give it an easy test. If you send out, go to traffic generator, set it to 60. Tell you what, I'll do it from this side. Gary, do you want me to? Doing it. Okay, go to the traffic generator, set up 60 byte frames. Short, sort of telnet frames. Alright. And let's broadcast them, and let's send 5% network utilization. Okay. Let's do 3,000 per second. Enter. Hey, right on the button. Okay, that's a busy network. Stop it. Not incredibly busy network. We're seeing terminal networks and terminal traffic that are busy now. Okay, let her go. Okay. Clear the screen. There's one on here at that station broadcasting. By the way, there's some other stations still doing their thing. We're watching all these frames go by. a buffer, of course, is filled. That's understandable. We've already seen 3.6 megabytes, 3.8 megabytes of data. We have no lost frames. Let me explain what the term means very precisely. For the sniffer, a lost frame means that the hardware got so backed up it couldn't buffer the packet, it just dropped it on the ground, it's gone from history. That's different from a buffer utilization. That's just a matter of, we've decided to put it in wraparound mode instead of stop when full mode. If you lose a packet, you've actually missed it. Okay, so we have a trace file. We're now going to collect this to disk so we can later analyze this problem. So I say run. And we're collecting light. I'm going to stop this thing and ask my straight man in the front. Before we said packets not saved meant things that get lost from its buffer. For the same reason, eventually it runs out. In this case, we're going to disk. What is this saying? The trace is being saved in the file. Guess what? Of 25,000 frames that were on this cable during this period of time, 17,000 are history. It kept 1 out of 3 frames. Not only that, but this is sort of its equivalent of lost frames. And in fact, couldn't even look at 5,000 frames. Okay, this is not a rigged situation. We can crank it back, we'll publish a report, but one of the problems with some of these statements like, oh, it can collect data to a disk file is, yeah, on what network, doing what, and so on. We have, let's look at another issue here. Let's, in fact, the answer is, I should tell you, the amount of data, the busiest network that you can monitor and collect to disk with an Exelan 5500 unit, their top-of-the-line unit, is 1% network utilization. Anything more than 1%, you lose data on the long-term average. How many people actually would like to, when they say they want to collect, days worth of data, are talking about a network that's less than 1% busy? Not very often. Okay, let's do another thing. Let's turn off this trace file since it's causing us such problems. And to do that, as far as I can tell, what I have to do is blank out this name. That's the way you do it. Then we can go back and start collecting again. So now we're side by side. We're collecting in the same packet, the same buffer. And now we no longer have this problem because we're not running to disk. Okay, the fact that we're losing packets here, we understand that that's just like the buffer overrun here. All right. By the way, how soon did this happen? Let's valve test here. A couple seconds, our buffer, got full. How soon does that happen here? This is a much bigger machine. It's about 2 megs. How long did it take before it started losing packets? It was 10 times longer, right? No way. 2 seconds. That was 1.5 seconds. I timed it. So all these claims about 2 megs and how many packets it can save, turns out aren't true. I'll go back to the question, and we won't be able to show it side by side. But it turns out that the sniffer packs its frames very carefully in its 256K valuable buffer. So we can put, for example, 3,000 short frames like this, or average frames typically, in a buffer and not run out of it. This machine, for example, doesn't pack them. It can never hold more than 3,000 frames. Despite the size of its buffer, in fact, does not take advantage of that hypothetical difference. It starts missing packets every bit as quickly in every real-world situation. Did anyone notice while we're doing this what's going on over here? Why is it doing that? I mean, I thought that had to do with the fact that we're backing up because of this hard disk. Well, the fact of the matter is, the LANalyzer simply can't keep up with 3,000 packets per second. We haven't lost the frames yet. The LANalyzer is dropping them like hotcakes. Let's see how busy this network is. Pause. Network utilization. Okay. So 20% busy network. Okay. Well, maybe it's because we're collecting frames. Another thing we can do is let's crank this up, and let's say for some reason we want to look at only frames to all routers. For some mysterious reason we think that's a problem. So we'll stop. I'll put on a capture filter. Just go up and say that I want to capture stuff to all routers. Okay? So here we are. Network is still chugging along. They're sending packets. Haven't lost any. There haven't been any packets yet to all routers. In fact, if you press down the home key there, it'll probably generate some. Okay. So bingo, there were half a dozen frames that went to all routers. Maestro. Now turn that time down, and we can go to about 0.25 between frames. And basically, this will get us up to around close to 4,500 frames per second. And we should still be able to not lose any frames. So change the time interval to 0.25. Okay, and it's still scanning the frames. It's not going to miss any. Basically, there are two different performances of these products. One is when it's just watching the frames and trying to find a few that are interesting. And that frame rate is around 5,000 frames per second, roughly, for the Sniffer, and closer to 3,000 for the LANalyzer. The LANalyzer is just in serious catatonic state here, and will continue to work that way. Let's try and set up a filter while we're here. Okay, let's capture frames just to all routers. You saw how we did it on the Sniffer? Okay, let's do that on the LANalyzer. So I guess I got to go over to my setups, I suppose. Stop, board, command, setup, and I'd like to collect stuff only to that station. The LANalyzer has a concept, which I should explain, called channels. There are 8 channels. Here are their names over here. And at the moment, 4 of those channels are active. And what a channel is basically each packet is being tested for certain criteria. The first channel is called promiscu. It's active, and I'll just step across. It says if that packet is greater than or equal to 0, less than or equal to infinity, take any packet, don't match a pattern, don't collect statistics, and collect it all. Then you should count it as, it matches channel number 1. And you can sort of tag each packet with up to 8 things it can match in order to be accepted. You would say we can have one particular pattern going, although we can then subdivide and see many more information about that channel. Maybe you want to turn off the audible thing.
You want to keep the...
Yeah. Why don't you just turn off the audible clips? Just let it go. Okay, so we're getting a different level of information. So let's set this up to only collect information going to all routers. So how are we going to do that? Let's set up, well, we have to invent a new channel, channel 8. Let's pick it. So I'm going to go over here, and let me first turn off these other channels, just so we can maybe see what's going on. Go down to channel 8, and turn it on. Now I've got to tell it and I'd like to only collect stuff to all routers. I want to set up some kind of address filter. How do I do that? Turns out that option is the pattern match option. And I go on and I turn on pattern match. And now, how do I say what it is I want to select? I hit F5 on pattern, and now I fill in that I want to get everything to all routers. At this point, I have to know the address of all routers. I think it may be a symbolic quantity that they can use there. I'm not really sure. Let's go over to Sniffer and find out what it is. Okay, it's AB00000300. Okay, so I'll type that in. AB03. By the way, again, I know exactly how to type because it says I'm in hex mode. Let's say I want to find stuff. In fact, it allows me to have a wildcard. Okay, I'm going to be lazy. Okay, I'm going to tell it, let's just collect everything to AB, hello, LANalyzer. Okay, just want to get stuff to AB. In fact, I've got to type in every character. I can't just exit a field here. And if I ever type over something, there's simply no way I can go back and change it. Once I've done something, it gets lost, and I can't reset or escape out of the system. I've got to continue ahead, fixing up this field. So it's AB 0, 0, 0, 0, 0, 0, 3, 0, 0, 0, 0. Is that right? Okay, so now I'll collect. Go back, and we'll say run. Set channel 8 to the right filter. This is a very common type of problem due to the design of the human interface. We'll now go back and look again at that pattern. And in fact, what happened was we were looking at the pattern, I guess, for the promiscuous channel. And what we have to do is, even though we were looking at it at channel 8, it threw us into a different pattern channel. So now we have to go back to F8, press F8, and now I can re-enter that. AB 0, 0, 0, 3. 0, 0, 0, 0, 0, 0, 3, 0, 0, 0, 0. Okay, so again, back, run. Now it's processing packets. Hasn't found the internal lane. Press the fast forward key there. So we get some. And so on. Okay. The mode we're in right now is kilobytes, and it's showing us that there were between 0 and 1 kilobytes from this station and so on. So we figured out there were 6 stations that were doing this, and here it actually has 6 packets in this particular case. Okay, why don't we go on and now very quickly just look at some of the actual analysis of these frames. Okay, so we'll just stop, press display, and here we have some, in this case, DECnet routing packets. Let's take a look at the kinds of analysis capabilities we have with LANalyzer. I'll stop and press display. Hit command. Okay. Trace. Right. Trace is display. And it's, there is the LANalyzer summary screen. Okay. Here is the Sniffer summary screen. We're seeing frame numbers. In this case, the length, time of day, destination address, source address, And what's this? Ether type. Remember that? Ether type. Everyone knows what that is. What, you know, all know, you know, ask the quiz what 603 is? That's, what's his name? Good old 603. Okay, well, that happens to be DECnet routing protocols. Okay, and if I want to do a filter on that, just to refresh your memory, for instance, if I wanted to have a capture filter on that protocol, I would go and I could specify the DRP ether type. Here I would have to remember the number 603 to do a similar type of effect. So it's really not decoding the protocol at all. It's just showing us this information. We like to put the length up here. This is the time of day. I'd like to change that to, instead of the time of day, to be the time between packets. I can do that by pressing Alt-W, jumps the cursor to here, and then I can press my plus or minus key to try another option, and it says relative timestamp. Now this is a fairly typical situation with this. If you look at this now, it says relative timestamp, but in fact, it's not relative timestamp yet. Okay? If I hit enter, then it goes into relative timestamp. So this is sort of delta time, length, destination address, and we can get a similar type of thing. If we wanted to see delta time and length, get that similar effect. We can also put up time of day. They can put up time of day. A number of things that the LANalyzer doesn't have. It doesn't have the ability to do some pretty important calculations. Now, the simplest of which is relative time. I'd like to find out the time between two frames. Let's go to a frame, press the mark key. Now I can read off, gee, this frame was 36 seconds later. That is not an easy thing to do with the LANalyzer. See here the block sizes and so on. It's actually interpreting DECnet addresses. As we saw, I can even display this using a DECnet address. So here we're seeing that this packet is from station 54.17, and again, every Decky knows what that is, to station 54.15. That kind of capability simply doesn't exist here. Alright, let's go and look at their decode of this. To do this, or to see the hex, I have to press this F6, packet data. And this is a decode, this is the DECnet decode of this packet. Do the same thing. On detail window. Here we're seeing the decode of what's going on. In this case, it's starting with the Ethernet information at the top and telling us the source and destination. Here it tells us the source and destination, uses a symbolic name. Decodes some of the fields noted involved, and provides some low-level capabilities, but no high-level capabilities. It will not decode things like file access, file messages, who's opening what files, going to printers. It just analyzes the lowest levels of DECnet. This example, we're not really taking advantage of that particular capability. We want to go into multi-window mode. Here, in fact, is 3 windows. That's pretty clear what they're trying to emulate here. They have down here a hex window. window. It's one line long. And I can scroll that window. And at the top, I have a summary window. I can scroll the summary window. So scrolling around to different packets, I want you to observe something. Do that with Sniffer. Notice anything else changing? Everything's changing, right? In fact, they're only changing this window. You're again leaving an inconsistent information. What you see in these windows is not what you're looking at in that window. And it's just wrong, and in fact, there isn't a way to tell by looking at the screen very well that that's in fact the case. If you look real carefully, this is number 11. Down here, this says packet 1. Okay? However, there is a way to do that. Okay? They have used our F7, F8, previous frame, next frame option. In fact, I can go to the next frame. So here I can do the same thing. F7, F7, F8. I'm scrolling around. The same thing. One frame, 11, whatever. Let's go to the previous frame. Push F7 here. F8. Pretty swift, huh? Really find your way around here. I think the main thing is, more than anything else, you just don't get to see at the summary level anything about the problem. Bring up a TCP/IP trace here. Okay, here we're seeing that was an NFS read. That's reading 3,000 bytes at location so-and-so. There is a UDP packet. Here is a telnet packet. This user typed the letter D, and this user responded with the letter D. The host responded. Okay. What you will see with the LANalyzer, you would see, we pulled up this trace in LANalyzer, is every single one of these would just be 0800 IP. Every one of these frames is IP packet. TCP/IP is running. That's all you would find out. Spend all day now looking through those frames in hex or otherwise at a very slow rate. And I think it'll be an interesting exercise. Just train to people. This is why someone who's used the LANalyzer, they can appreciate the Sniffer. By just sitting down with the real problem and trying to sort their way through it and find out how long does it take to find out why is the system broken, what's happening here, who's talking to who. Right away, you can see exactly what's going on, decode it, all the way up the application stack, and this provides low-level information, and at most a decode of just levels 1, 2, and 3 up to the routing level, not 4, 5, 6, and 7. Mention one other detail, which is a new feature in Sniffer, a new feature in the LANalyzer in this version. I'm going to turn on a mode called high-speed mode. And here in the LANalyzer, try and do the same thing. Cut machine to 60 byte frames, 0.04 apart. Let's do the same here. In this mode, in high-speed mode, or in their high-speed mode, there are no filters. It's not writing to disk. It's just keeping stuff in its bucket. Okay? As fast as it can. At this point, 60 byte frames, 0.04 between each. Okay, we now have two machines transmitting, one on top of the other. Okay? This network is going at 14,600 frames per second. This is the worst case loaded maximum Ethernet system. Okay? Let's do the following thing. Why don't you stop this and go over to where it says count. Enter the number in the traffic generator. Same here. Just stop it and put in the count 150,000. Stop both these. Where it says number of frames instead of infinite. Put in 150,000. 150,000. Stop for a second. Stop. Let's get these guys in sync here. Okay, gentlemen, start your engines. Okay. Now basically, you're going to send a total of 150K and 150K. Two machines are both going 14,600 packets per second. Both of them at high-speed mode, guaranteed not to lose a packet. And they both got 300,000 packets. And that's my final act, gentlemen. Wait a minute. Who is it? Raj? You're the numbers man. What we lost 94. Get out your calculator. 94 out of 300,000. What percent is that? Let's get it right here. 0.03%. What is? I mean, it's 99.97% capable of keeping up with busy. I mean, close enough for government work. GSA approved product. Let the jury decide. I rest my case.